Well, hi, good morning. Thanks so much for joining me in my shop here. It's October 24th, and it's time for me to face up to the problem with this particular radio. And it's not a simple problem to sort out, at least I haven't found it simple so far. So the problem is the oscillator on the two top bands does not operate. The local oscillator doesn't oscillate. It does on the lower bands and seems to perform just fine. But on the two bands, there's no sign of it whatsoever. I discovered this on an earlier video when I worked on this radio quite a long time ago, and concluded that I shouldn't continue with the radio until I'm operating it from its own internal power supply. I had been operating it from power supplies. Up until then, I didn't have the big speaker. Now I've got the speaker, I've got the tubes, I've got the set operating from its internal or normal power supply in the normal way, and the two top bands still do not operate. The local oscillator does not oscillate. So I think this is a very difficult problem. It might be easier if it never oscillated on any band. That might be an easier problem to track down. But failure to oscillate just on the two higher bands, I think is going to be it has been challenging. I think it will remain very challenging. One of the things that's in the manual for this radio, which you might find in the better service manuals, is a chart of all the pin voltages for all the tubes. So I'm going to utilize that. I think the first step I want to take is utilize that chart and check these voltages. Now there's a warning in the manual that while you're doing this, if you're using a type of equipment that some repair shops would have had, an analyzer, and I believe you bring over a multi-line cable and you connect it to your radio here and there, there's a warning that hooking that cable up may cause some things to oscillate that shouldn't, and may prevent the local oscillator from oscillating. So that's the situation here right now, is that the local oscillator is not oscillating. The implications of that is just the fact that it's not oscillating will cause the voltages to go off on the oscillator tube. So as I read them and compare them to the chart, and the expectation is they are working when you make these readings, I'm bound to get readings that don't match the chart. It's really only telling me what I already know. Nevertheless, I think I'm going to go through with the process anyway. There could be other voltage problems in this radio undiscovered yet, and although it's going to take quite a bit of time, I might as well do it. I'm going to do it off camera because it's rather boring, and I'll just keep a chart of the results and then discuss on camera what the results were and what the implications are and what's going on in my head. Well, I may not discuss that last part because I'm really not sure what goes on in my head. So. Okay, here's part of the alignment procedure. This is for the automatic frequency control, but I want to read this part. This is the chart here with all the voltages on it. And here's what it says. Socket meter readings below. The meter readings given in the diagram are taken with the antenna and ground binding post short-circuited and with 120 volts line. All readings are actual operating conditions, and in some cases it will be necessary to allow for meter resistance. So what they're warning here is that these voltages are almost the theoretical voltages that should be there when no voltmeter is connected. And if you connect a voltmeter that puts a load on the circuit, you're going to get different readings. So they're just warning you to allow for meter resistance. Now I'm using a excuse me, a VTVM with a very high resistance, like most meters are today. But back when this was being done by repair guys in dark rooms, their meters were crappy. All DC voltage readings are taken with respect to the chassis frame. All readings are given for normal operation. So I have a radio here that's not operating normally on some bands. So I'm going to start off with the radio switched to a band where everything works normal. And I'm going to do the readings there. If readings are taken with a set analyzer, circuits that are not intended to oscillate may oscillate, thus increasing plate or screen voltages and decreasing plate and screen current. The set analyzer cable may also cause the oscillator radiotron to cease oscillating, thus increasing current and decreasing voltage. So on the two higher bands, the radiotron, it's not a radiotron, the tube is not oscillating. So you would expect an increased current and decreased voltage, according to this. So what this is saying to me is there's some sensitivities in this radio when it comes to the oscillator working properly. And it's sensitive enough that hooking up test equipment can throw it off. So I shouldn't be too surprised if it's not oscillating on a couple of bands because it's this sensitive. So I draw your attention to something else here. Let's just zoom in a wee bit. The complicated speaker situation. Look at this over here. So here's the field coil. That's simple enough. Two wires coming to it from the plug. So that's just the field coil sitting as the filter in the power supply. It's what's going on the other side of this output transformer. So I have a couple wires coming to it from the plug. That's normal. On the secondary side, things aren't so normal. It's got two windings. So one of them is this one, which is clearly driving the voice coil and going through this hum neutralization coil, which I believe is bucking the effect of this coil sitting so close to it. I believe that's what it's doing. Somehow I get this story wrong all the time, so once again, don't swear by anything I say. Keep your own thinking cap on while I'm doing this. Hopefully the things I say that aren't right are harmless anyway. Often I sort of recognize that if I'm not correct, it doesn't matter anyway, and I just move on, and I never comment on it. It's just something flying through my head. Yes, there are things flying through my head. So this is interesting. This is very interesting. What is this doing here? 0.07 microfarad. Pretty sure that's what that says. And a little coil here. What's this guy doing? I don't think I've ever seen that on another transformer. So obviously it's affecting the speaker sound somehow, or they wouldn't do it. Very curious to me what that is. But it's of no consequence for what I'm doing right now. The first thing I'm going to do, I'm going to turn on the set. I'm going to get it operating so we can hear a station. Then I'll short the antenna. Just to, I guess that's to make sure there's no signals in some of the tubes. And then we'll do this long resistor here, and we'll look for all these voltages, all the way from 250 to 0 to minus 14. And we'll see if that's there. Some of these things I'm doing I may have done a year ago. I certainly need to repeat them again. So if you're watching the video series from start to finish, not concurrently as I'm posting them, then that mysterious 8-month gap isn't apparent at all. You've just gone from one video to another, but 8 months went by in between. So if I repeat things, for instance, let's go back to the camera here. For instance, if I should discover that the antenna ground is done oddly here, as I did yesterday, hey, I discovered after I've done these videos, of course I spend time thinking about what I've experienced and that, and sometimes as I roll it over my head, some memories come up and stuff like that. So yeah, I found this thing, this weird connection, I'm pretty sure 8 months ago. I found it again yesterday as if I'd never seen it before. So yeah, not only is my short-term memory shot, I don't have any long-term memory to go with it. So great thing about that is you don't even remember that. Okay, let's get the set operating here. I made a large version of that chart for note-taking. Okay, we'll power on here. Go through the dim lights to start. Switch it on. There we go. The lights are glowing over there. That's fine. Still have my antenna hooked up and switched on. We're going to go to the AM band, which I think is all the way this way. Be careful with the volume so as not to blow our ears off. Let's give it full. Oh, volume. And my hand on the tone control there. Okay, well that certainly seems to be working. Let me tune just a little bit. Sure. Okay, we're going to get rid of the antenna. And we're supposed to put a short on there. A nice teeny little short. I don't have a teeny one handy. We'll just do it like this. That's going to be enough of a short there. Imperial. Let's turn it up. Okay. You know what? Let's not rely on this. And we'll go here. This was the big surprise yesterday. There we go. Jeepers. These are lousy terminals. I'll have to clean those guys up at some point. There we go. Put the volume just a little bit up in case something happens, we'll know it. Okay, the actual voltage coming to the radio this morning is 119.8. That's pretty close to 120. Voltmeter set to DC plus. 500 volts full scale. That doesn't help, does it? Okay, a little difficult here getting. Let me just do this. That might just make things a little bit better. Okay. So the first voltage is supposed to be 250 volts on the 500 volt scale. That's straight up. And that's right here. So we're closer to 300. And this meter is fairly well calibrated here. So looks like it's just under 300. That could be because of the tube I have in their rectifier. A little extra voltage. I mean, that's got to be good for you, hasn't it? So we expect it to be a little high all the way along here. The next voltage is supposed to be 100. So we'll go on the 150 scale. 100 is here now. It's right on the money, oddly enough. Next one should be all the way down. 4.5 volts. Is that what that says? Wow. Really? 4.5 volts? 15, let's see, 5 volts full scale. Yeah, you know, it's right on the money. 4.5 volts. Oh, what was that? I wasn't doing anything. I don't have the volume up that high either. It just did, maybe that tickled. It must have tickled the radio a little bit. Next pin should be a 0, because I guess this is, there's no 0 there. 1 volt. Next one should be 1 volt. 1 volt. Okay, on the 5 volt scale we're at 1 volt. And now the last one is a negative voltage, 14 volts. We're on the 15 volt scale, so it should go just about all the way over. It goes a little further. Let's try that on another scale. We're on the 50 volt scale now. 15 is right here. 14 is what we're looking for. 18 is what we're getting. So why that is exactly, we don't know, but everything looks pretty good. I'm going to mark down the 18 volts. It's involved, you know, it's just part of the bias of the output tube. I don't know if it's doing much more than that. But 18 is just a little bit different than 14. Okay, that was the exciting thing there. Is there any other sort of overall voltages here? I don't think so. So I'm going to start by focusing right on the oscillator tube. This diagram sits like this. Oscillator tube is the third one up. 1, 2, and 3. It's right up in here. I'll go around and check the voltages on it. And you know, because this is the key tube, I'm going to keep the camera rolling here for this. So we should locate the key, just pointing in that direction, and then find pin number 1. Just start there. 0 volts on pin number 1. I have to get down on my knees. I'm standing on a rubberized mat. I'm now kneeling on a rubberized mat. And let's just bring a little more light into here too, for my sake. There we go. Very good. I can clearly see everything. Pin number 1 is right to the ground, so there can't possibly be a voltage on it. Pin number 2 is an AC. We're going to skip that. Why are we skipping that? I'm assuming the heater voltages are good. AC, 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 15 volts on the scale. Pin number 2 is a heater. Are you really? So now that's interesting. So on this meter, and I don't know how well calibrated it is on AC, it's reading 5.6. I'm not sure about the accuracy of this meter. There. Let's bring out what would normally be a much more precise meter. Just looking for my meter stand. Where'd he go? Where'd the guy with the hands go? Here he is. Laying down on the job. Okay, we'll go on to AC, 20 volts. Nothing in me. That was the thump voltage. Okay, so we're going to go 1 lead on ground on the chassis and the other one onto this pin here. 1, 2. We get a 6.5, and now that's probably a very reliable reading. So should be, 6.3. Can't complain about 6.4. It's certainly within the range of the tube. Yeah, it would have to be quite a ways off to really throw the tube off, I would think. Okay, back to DC. On this tube, the next one is 175 volts. What we expect to see. Let me get down in the praying position here. 175 volts. So on the 500 volt scale, 175 is coming up here. Okay, 1, 2. Happens to be the same as this spot right here. We're on negative. We're on positive. Same spot as this. Ooh! Ding, 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 ding. Well, what happened there? Let's go right down here. This is pin number 3. We are on pin 3. Their actual reading is, on a 500 volt scale, just under 150. Let's go to the 150 volt scale. 145. 145. So we may have found something already. This is a plate of the oscillator tube. Okay, so 145, that's going low. Okay, next one I'm gonna guess, I can't read it in the little diagram here, but I think it's probably the screen. 175 volts also. Very same voltage. Okay, get the right tube now, Jim. Well, this is Okay, so that's the one I just tested, just double checking it. Just under 150 instead of 175. And the next one, well, it's exactly the same. It probably has to be the same. They are on either side. Like this is one pin and this is the other pin. There's just a coil in between. So how different can they be? Look, the insulation is off right there. That high voltage sitting right there. Whoops. On that red wire, ready to bite me. Right there. Right there. So the two of them are low. That could be the problem right there. And you'd have to wonder why. Let's keep going. Next one is 0. They have milliamps on some of these too. Next one's 0. It's a heater. I know, what is it? I don't know. Next one is not measured. Next one is 0. The last one is minus. Oh, that's a current. There's a current there. 6 point, looks like 8.5 milliamps, but the voltage looks like 0. It's not helping much. Let's check out the all these. So it's basically 0 volts from then on for every next pin. Well, is it? Okay, 150 volt scale. This is set to DC, right? Yeah. Okay. Next one, 0. Next one. So the next one is the not measured one, and I think there's no pin from the tube, so they're using it as a terminal. So it doesn't matter what I get there. At least I didn't record it. This one is right hard onto the chassis. I can see how it's soldered to the chassis. Next one, you can hear that. That's probably a grid, eh? And that's the last one, pin number 8. Pin number 8. Pin number 8. Cathode. Cathode. If a cathode hard grounded, soldered in there quite solidly. It's a little hard to see on this camera now. Let's try this. There it is up there. What's happening here is you can see, get my hand around the camera. So there's the key. This is 8. No, it's not grounded. It's not grounded. It's not grounded. It's this one that's grounded. You can see the big solder grounding. You really didn't fool around there. So what do we got? We got a low plate and screen voltage. A little bit low. There's the plate voltage low everywhere in this radio. So pick another tube in the area there that may have a similar sort of feed to it. Maybe we'll pick the 6K7. It's way up there. Let's go back up here. Hey, what are you looking at? Keep your focus, literally. We'll pick up plates. It's the same. I'm looking for a similar voltage, 175. Who else has a 175? Going once. Going twice. I don't even see any high voltages. Oh, yeah, 130. Nobody else has a 175. 250. 250 on that guy. That would be this tube here. He is supposed to have 250 volts on the plate, which is 1, 2, 3 again. 3. And the key is not where they show it. Yes, it is. Down this way. Just kind of doing a double checking thing and make sure I'm on the right spot, because I tend to get these mixed up. Where did I see it? Plate 250. Could be 230. It's a lot anyway. Okay, third one in. What do we get? We're on the 500 scale, so 230 is going to be just about straight up. On 1, 2, 3. This wire here. So there we are. It's over. So well over 250. Okay, so generally it looks like the B plus is not low. It's low specifically here. Another tube that's involved in the oscillator system here is this oscillator control tube. And this is where they do the automatic frequency adjustment using this tube and some technique I don't quite follow yet, although it's described well in the manual. I should say I don't recall. Actually, I don't recall ever understanding it fully. So why don't we check this guy out? His plate looks like, it's hard to read here, 150. That tube is this tube, and 150 be on. Let's do this the right way here so I don't confuse myself. Funny squeaky sound coming out of the radio there. 1, 2, 3 from the key. It's 3 again. Okay. There's the key in the right spot. This is 3. 3 comes here. What are we looking for again? 250, wasn't it? 150. We're on the 150 scale. We'll see if 150 is 150. 150 scale. Too many numbers said at the same time. I'm going to crash this airplane for sure. 1, 2, 3. 3 is here. And it's 140. A wee bit low. Or am I reading this wrong? Like that could be 160, 180. That could be 180, and this could be low. It's not legible. This version here, this teeny tiny version. Yeah. Oh, it looks more like 180. How about on the teeny tiny version with a magnifier? Okay. Teeny tiny version is. Wow. Could be 180, could be 160, could be 150, could be 130. Okay, we can't be sure, but it's just as a guess, it seems like it's a little bit low, and I wouldn't be surprised if those voltages are somehow related. Now wait, isn't there a screen voltage on this guy too? Shouldn't there be a screen voltage? Let's do this one. Screen voltage. So hard to see. Plus 100. The next pin over should be plus 100. Okay, a 150 volt scale. The next pin over would be this one, and it's casting along from tube to tube. Ooh, it is. Are you really? 1, 2, 3, 4. Okay, so we're getting just under 100 here, 95, which is certainly close enough. So 145 versus 175, that's a 30 volt variation out of a little under 200. That's about a 25% off. Does that make sense? Doesn't quite seem right to me. It's more like, well, it's off. This could be a very critical tube. Getting it to the right voltage could be very critical. And I'm on the band. Hey, I'm on the band that's working. Okay, let's go to the bands that do not work. Still hear that funny sound. These are the bands that do not work. How can I know for sure that I'm on the right thing? I think that proves it right there. What I did was I pulled the ground off my little shorting of the antenna and nothing happened whatsoever. Okay, where are you going, camera? Stand still. Okay. Now, yeah, so now I'm on the other band. We'll do those same oscillator voltages. 175. Right tube in the right angle. Three and four. Same two pins all the time. 3 and 4. Okay. Back into the praying position. We're on 150. We're looking for 175. 500 volt scale. 175 in this range. Here we go. 1, 2, 3. Yeah, it was these two, wasn't it? Oh my. We're supposed to get 175 and now we're getting 100. Okay, let's do the band switch. We'll watch this voltage. What was that? That's me wiggling here. I'll try not to wiggle. Look at that. Line there before I get a big surprise. Okay, well, we definitely found something here. I think we really zoomed in on the cause of the problem. We need to look at the schematic and ask ourselves, well, what is it that could be happening here? What was that statement? There was an interesting statement in here. It said, if readings are taken with a set analyzer, circuits that are not intended to oscillate may oscillate, thus increasing plate or screen voltages and decreasing the current. So you decrease the current, you decrease the voltage drop through any resistors that are in the circuit. The set analyzer cable may also cause the oscillator radiotron to cease oscillating, thus increasing current and decreasing voltage. So it doesn't oscillate and we get a decreased voltage. Okay, just what I said. I'm gonna just kind of rediscover what the problem is, but I think the hint is that there's a resistor that's gone high in the circuit somewhere. Okay, circuit diagram. Not there. Not there. It's here somewhere. Wiring. Where are you, circuit diagram? Where'd you go? Where'd you go? It's right there. Well, this chart appears twice. Maybe there's a cut and paste thing that's happened. Somebody's cut and paste stuff. Maybe this is a little bit clearer. This is maybe a little bit clear. That looks like 180. 175 for sure here. Not much clearer. Let's look at the schematic and ask ourselves, who could the bad actor be? Let's just shrink this one more here. So I want to look at the oscillator tube. Here's the oscillator tube and all of its friendly coils, and down here is the control tube. And notice they're both 6J7s. So if we look at the plate circuit and we say, who could it be? Is there a resistor? Oh, here's one. Looks like 470 ohms. That's not much. It's here, and then on the takeoff for the screen is here. This guy's getting his plate from, oh, where is he getting it from? Oh my gosh, he's getting it through this coil. Here's another. That's a whopper resistor, 10K it looks like. And then from here, where's this 470? Where is the 470? It's R, who knows? R looks like R6, but I can't read that. R6. It's going to be a little, where's that diagram? Where's that? Here somewhere is the wiring diagram. Yes. Okay. A fantastic diagram. This is the tube I'm fooling with. There's an R8 470 right there. R looks like 3. 470. It's right on the side of the socket. And sure enough, there is one right on the side of the socket. 470 that's an unbelievably low value. Let's take a look at it. There he is. Turning the set off in a moment, but it's still on. Jim says, reminding himself, it's a little quiet. That's the volume control there. That guy right there, that guy. He's a body and dot. A yellow, that's 4, and looks purple, 47, and the dot. That's a really high resistance. It must be 470K or 47K. Okay, let's turn the power off. We will measure that guy. I'm going to check for any residual voltage here. A little tiny bit. Same sort of little tiny bit. Looking at my meter here, it's way on a high scale. Can't do an ohm reading with that sitting there. Slowly going down. Okay, we could help it along. So I am too impatient to help it along. Trick. See my hero there? Yeah, of course it says nothing. That's my hero right there. Terry Fox. Terry Fox. My greatest hero. Next to my father, of course. Yeah, when you're feeling bad and feeling sore and just feeling like you can't keep going, you just got to think of that guy, Terry Fox. I saw Terry Fox, for real. My wife and I were driving to Sudbury in Ontario, and we're driving on a highway. That's kind of all there is up there, is highways, one highway, two highways, and back roads. Driving on the highway, and up ahead I can see a vehicle driving slowly on the side of the road. And as we approached it, I could see in front was Terry Fox running, and he was maybe, I don't know, 200 feet ahead of the vehicle, 300 feet ahead, all alone. And he had this very characteristic way of running. Terry Fox was trying to run across Canada with only one leg because he'd lost his other to cancer. And there he is, and we took a photograph as we went by. My wife snapped a photograph, and I wish I could pull that photograph out and show you right now. I don't know where it is offhand. It's a classic Terry Fox shot. He used to run with his, he'd have his hands up like this when he was running. Yeah, saw him for real. Okay, enough memory lane stuff. This will be discharged now, I'm sure. But let's just be sure. I'm sure, but be sure. Sure in your head is nothing. Still a teeny tiny amount there, so it's probably coming out here. Let's see, is there something down here? Nothing there. How about this guy here? Nothing there. It's coming from somewhere. Maybe I should leave that on, and I'd have to put it on both sides, and then I'd have the resistor shorted right out. Can't very well make a the resistance reading that way. It's wonderful that the world has decided to remember important people by using their names to name various electrical values, like ampere gives you amp, and voltaire gives you volts, and oh, I forgot his name, Ohm. Mr. Ohm gives you ohms. The problem with that is that those words don't mean anything. That's unfortunate. So, you know, it'd be better to call voltage what they used to call it: pressure. The pressure and the current. Okay, we're going to try now. See what we get. It's something like 47K. Right in the circuit. What do we get? Can we believe it? Whatever we get. We get what? Okay, so that's because I have this on. Let's take this off. That's got to be because one side must be grounded. Okay, here we go again. What? Zero. So is there what? Okay, let's go back and see if we can explain how you get a zero. Now there's lots of stuff around there. It's probably a coil doing it. Probably a coil doing it. Let's take a peek. Not here, but here. So I just put my ohm meter across this guy in the circuit, and you can see there's stuff going all over the place here. Up through here. Dead ending at the plate here. Wait a minute. If it's dead ending at the plate, and this way is dead ending at the screen. Let's do that again. So, I mean, if one side of the resistor is going nowhere, I should be able to make a resistance reading. I seem to remember being caught up in this coil like a year ago. Plate. Oops, I came down the wrong wire. Well, there's nothing there. And up here, it's just this guy, C12. You got a short on C12? If this were shorted to ground, then that would be a bad thing. We wouldn't get any voltage on the screen here. But we did. The chance of this resistor being zero is like zero. Screen on one side. Now, does this somehow come back around? Not going to do it. Goes into here, comes back on this other line. Wow, plate. So it's open. Capacitor here to a tuning capacitor here. I think that's what this is. Tuning here, here, and up here. This is the capacitor that's tuning against these coils. What's happening here? How did I get that reading? How could that be? Go back this way. really getting into everything in the radio here. Okay, there's a resistor here. And the nearest ground is far away. Oh my gosh, yeah, far into here. This was all reading good. Well, you know, the one conclusion is somehow the resistor has developed a short. Really? Let's take a good close look at that. Maybe I developed the short in it by making some kind of mistake. Hard to believe the oscillator would work on the other bands. Yeah. Didn't I say something about I wasn't going to video this? I would just do it and then I would report. I often come up with plans in here and then a moment later I'm in another direction. So, well, I could just cut it out of there and stop fooling around. But let's keep fooling around. Let's take a close look at this. Come on, camera, there we go. So I put that yellow resistor in, capacitor in. That's an example of me misspeaking. You must hear, oh, is that actually touching the ground? I'm sure it is. Let's just be doubly sure though. Stick your finger in there and wiggle it. Yeah, it's. Looks like it's poorly soldered. It's on there. It's probably good enough, but it can't really cause the kind of thing we're having happen. Come on, camera. Okay, so the camera's fighting with me. I am going to win the fight. While you take a good close look at that fuse there, just bear with me for a moment. I'm going to freeze the focus on it. Today, if you're watching this on a large screen, you might see an improvement in the quality of the video here. Because embarrassingly enough to me, I did not have everything set as high as it could be. So for quite a few months now, I've been doing videos at a lower video quality than is possible. Shame on me. Now this particular camera, actually, it can only do 720. Oh, this just doesn't look very good, doesn't it? Let's just wiggle this. You know, it looks terrible, but everything is connected together in here. That's the terrible thing about taking a close look at your work. And the other problem is I'm looking at the wrong tube. That's really the big problem. Okay. There's that yellow resistor. Why? It would read 0 if somehow that terminal was grounded. Or would it? Or would it? I don't get it. I just don't see anything here that would explain it at all. I mean, there's nothing going on here. I'm not one for changing things that don't need changing. I think the only thing I can do is cut it. Once I cut it, I'm going to have to replace it. I'm pretty sure I'm going to cut that, and it's going to be okay. That's what I'm going to find out. So I don't want to do this. And I'm looking at this page for no reason. I'm losing time for a coffee break. It's time for a coffee break. Yeah, 45 minutes into this. Coffee break time. Just spent a couple minutes with my coffee cup and the TV, and I'm watching that show Mayday, which is about airplane accidents. And just for those couple minutes, I got to watch a pilot foolishly crash his airplane. Am I going to crash this radio? So I decided, well, you know, I've got one measurement done with this meter. How do I know I didn't do something stupid with it? Why don't we try another instrument here, which has a chance of working better with the, I don't know, we'll see. Damaged part. I think that means basically it's analysis. I think this thing operates with frequencies and various ways it applies its test. And what it's concluded is whatever those results are can't be the case. It shouldn't happen under any circumstances. And so if it was 0, though, it would say 0. Let me read it again with this meter. Somebody hand me a resistor. Thank you. $72K is what that is. Okay. It's okay. One more time. 0. Can you know, in my experience as resistors go high, 0, 0. I'm getting a 0. Bring them back. Because we're gonna cut one leg. I'm gonna end up replacing this resistor now, no matter what. I'm gonna cut one leg of it. Okay. A little bit, and now it's going to give the proper reading. I've been down this road so many times, but they know what else to do. I've got to do something. Zero, it just doesn't make sense. 0 for so many reasons, and the answer is 0. How? Let's bring that other instrument here. I mean, that's pretty convincing. Or is my meter battery so low it doesn't make sense. I tested a resistor. Sometimes there's things in your head where you say, oh, it just can't be the case, but you go ahead and do a test and find out it can be. A resistor, 500 ohms. Well, it's reading 0 because I have this up on such a high scale. Okay, that's why it's reading 0. 500 ohms, because I'm thinking this has got to be a very high one. Did I get something on body and dot? You know what? You're a dummy, Jim. 469 is supposed to be 470. It must be the colors are off or something. Body and dot. So that would have to be 47, and then it would have to be brown. Well, I guess it could be brown. It sure looks purple. Oh my gosh. Throwing off. How many times have I been here? Many times. Okay, so we'll set this to 2,000 ohms. That'll give us a nice number there. The 0 is there. I should, could have done the simple thing and changed the scale on the meter before I went and did what I did. There it is, 470. It's dead on the money. Jim, come on. I just crashed my plane. You just solder that guy back? I don't think so. But I'm going to. Okay, I'm going to solder that guy back. Well, we know that's not the problem. for something else now. Well, there's something a little difficult about soldering in there. They've used some kind of solder that seems to want to melt at a higher temperature, so I just can't get the short little lead on that resistor into the solder. So I thought, well, I'll replace it. I've got lots of exactly the right resistor, the right wattage and everything. So here's what's happening. Here's one. 529. Every one of these is measuring 520. That one measured 529. What happened to the 470? 470, yellow, purple, brown, with a silver band. I got piles of them. That one's better. These are brand new. They've never, well, brand new. These are probably pretty old, but they've never been in a circuit or anything. They wouldn't necessarily be that old. Maybe 20 years old. 524. Very consistent. What's going wrong here? Let's see if I... So the way I keep my resistors, I have a tray that says 47. So it's everything from 47, 470, 4700, all the way up. I just have to look in here at the third band for the right color. So the color, third band color is brown. So it's pretty quick to pick one out. So sort of quick. Let's pick another one of a different sort. 470. That's got to be brown. There's one. Yellow, purple, brown. What's going on? I can see the rabbit hole. It's just, I'm standing at the edge of the rabbit hole here. 470 exactly. What's going on with these resistors? Now, you know, the way they make resistors, especially in the earlier days, was they come off the end of the assembly line or however they were manufacturing them, and they weren't necessarily exact, but they want to throw them away. So they arranged those categories, those strange resistor categories, so manufacturers could take them off the end of the line. They're going to go into one box or another. They're not going to throw them out. So you can't expect, especially older resistors, to be precise. 533. Every one of them has gone high. Look at this big whopper. Just checking things out again. That's a 47. That's 4700. Well, that's disappointing because I thought, wow, look at that, man, I got tons of these. But I think in this case we want to put an accurate one in there. What about if the current is flowing and that resistor heats up, then it exhibits bad resistance? I can't believe that. I'm going to have to look harder now because that's my supply of the perfect resistor, and none of them worked out. Oh my gosh. Look at, see, jackpot. See what's happened here? I cut that resistor away for no good reason, and now I'm stuck in a jackpot. Just what I didn't want to have happen. Okay, now I've just become interested in resistors. Here's a whole bunch of 470 half watt resistors. They're too small, but very hard to tell. That looks like red. That looks like a red third band. So brown can look like red, brown can look like purple. $472 ohms. Lovely, but way too small, too low a wattage. This is very unfair. This is very unfair. Ooh, okay, so I opted for soldering it back. I'm just trying harder. I managed to get it soldered back okay. No, I didn't. No, I didn't. Oh my gosh. What is it with the solder there? I turned up my soldering iron. So what I'm doing here is I've fashioned a piece of metal here to act as a spring to push the resistor into place. So I've got my two hands free. Look, the solder is just clumping up on here. What is going on with their solder? And now I'm going to try to just drench this guy, so to speak, in solder. The spring will hold it in tight while I'm doing it. Okay, everything's melted. Beautiful. Melt over the top. Oh, my spring is moving. More solder. I kind of knew this was a possible outcome of nipping that resistor, but come on, solder, get on it. Ooh, looks good. By now I've wrecked the resistor. Okay, I don't think that's gonna. There. Wow. There it be, in place. Let's take, I'm going to just gamble and use the close-up camera and take a look at my lousy solder job here. Wow, it's just, it's definitely, it's, yeah, wow. It's probably good enough. Do I dare pry it? I must pry it. I don't see how it can come out this time. Okay. Yeah, I just took a piece of tin here and just bent it, jammed it in there. The sharp edge kind of bites on the resistor a little bit to hold it. Third hand. That's what a third hand looks like. Well, now what? Now what? Hey, let's see if that fixed the radio. Really, just all those resistors coming out wrong by roughly the same amount. Disappointing. Unless at some point I need a 520. How would that suggest those resistors are going to drift high as soon as you put them into operation or something like that? If you heat them up. Resistors everywhere. Okay. Radio, do not resist. So I've hooked up a clip lead to the meter probe. Meter over here set to 500. Power on. Is anything exciting going to happen? Maybe. So dim bulbs, wouldn't imagine so, but hey. The guys who crashed that plane, they didn't think they were going to crash. The way those guys crashed their plane was they switched to visual flight rules, which is now illegal, and then another plane crashed into them in the sky because neither plane could see the other. Okay, what do we got here? We got a little bit of voltage coming up. I'm on the AM band. Oh, what was that? Chunk. That's way off where it's supposed to be. Or is it? supposed to see 175 there. Am I actually on the right spot, or have I done 1, 2, 3, 4 pins in? And more light. Oh, 1, 2, 3, 4. Well, actually, I'm on the wrong side of that resistor. Okay, I'm going to pull this clip lead off. I had a hard time getting it on there. Did not want to stay. Let's check carefully now. We should be, hold it this way, if I'm not confused. 1, 2, 3. It's 3 and 4. That's right, 3 and 4. 3 and 4. Okay. 1, 2, 3, and 4. 3. Oh, that's low. This wasn't low before. I've wrecked the radio. And here. I've killed the oscillator on all frequencies. Is that what's happened here? Oh my gosh! I feel that today's session is coming to a quick end. I have once again wrecked a radio. Let's turn the volume down. Ooh, the volume's way up. Take off this little guy here. No short. I must be right in the zone because I've killed it completely. Oh, wait a minute. You know what? We're not on. We're only on 68 volts. No, I haven't killed anything. Come on, man. Wacko. You can hear things heating up in there. Okay, repeat the test. 120 volts now. Okay, on the AM. That's certainly not reassuring at all. .500 volt scale, looking for 175. We are getting only 500. We're getting 150. 150 there, and be the same thing here, wouldn't it be? Here. 150 on the 500 scale. It's supposed to be 175. Okay, changing bands. Now that sounds like it's working. Exactly the same effect. Except if anything, it's worse. Okay. So there's a local oscillators there. AM band. Yep. So 150, it's doing the job. But it appears. Oh, it seemed to be there and then just fade. Quickly tune. Doesn't seem like there's anything there. And the last band. Even quieter. Well, we didn't get anywhere. back to the starting point. I guess that's somewhere. Well, we know it's not that resistor. Yahoo. Yeah. Okay. Well, thanks a lot for watching this. That's the end for today. And tomorrow I'm just going to keep plugging away at it with something. Something has to be out of sorts here. Should retest the tubes. Probably that's going to be a good move to do. I never did test all the other voltages, but I'm not too worried about them. It's really about this tube and the oscillator circuit. Okay, well, thanks a lot for watching. See ya.